Welcome all. Myself, Shamla Devi, working as an assistant professor in the Department of Electronics and Communication Engineering at K.S.Rangasamy College of Technology. Today, I am going to take about the concept of modulation techniques in communication systems. So modulation is the process of changing one or more parameters of a high frequency carrier signal, example amplitude, frequency or phase change in accordance with a low frequency message signal. So the message signal contains the actual information, for example speech or music. So this message signal is also we called as a baseband signal. So these baseband signals cannot be transmitted as it is efficiently over long distances. So they are combined with a high frequency carrier using the process of modulation. So this process of modulation makes long distance transmission possible and efficiently. So this modulation process is essential for several reasons. For example, when we try to transmit a low frequency signal directly, it would require a very large antenna and the transmission efficiency would be of very poor. So modulation helps in reducing the size of the antenna by improving the radiation efficiency of the transmitted signal by increasing the communication range and minimizing interference between different signals. So without these modulation technique, modern communication systems would not be possible. So why we need a modulation is that the first important reason is practical antenna size. In order to reduce the antenna size, the modulation process is needed. So low frequency signals are not efficiently radiated into free space. And a large amount of power gets wasted during this transmission. So when modulation is applied, the signal is transmitted of higher frequency, which improves the radiation efficiency and ensures that the transmitted power is efficiently utilized. Another important reason for modulation is to avoid signal mixing and interference. If multiple low frequency signals are transmitted directly, they will overlap and interfere with each other. So modulation allows each signal to occupy a different frequency band, making it possible to separate them at the receiver side. So this enables multiple users to communicate uh, at the same time without interference. So next one is when we follow all these steps, we can also minimize signal mixing, and then modulation also helps in increasing the communication range. So high frequency modulated signals can travel longer distances with less attenuation compared to low frequency signals. So this makes long distance communication possible. For example, when we take satellite communication and all radio broadcasting, long distance communication is possible with the help of modulation technique. Modulation also improves noise performance. Most types of noise affect the amplitude of a signal. By choosing appropriate modulation techniques like frequency modulation technique or phase modulation technique, the effect of noise can be reduced. So this results in reliable signal reception at the receiver side. So what are all the types of modulation is that amplitude modulation, frequency modulation and phase modulation. We will see one by one. First one is the amplitude modulation. In amplitude modulation, the amplitude of the carrier signal is varied in accordance with the instantaneous amplitude of the message signal, while the frequency and phase of the carrier wave remains constant. Amplitude modulation is simpler to implement, and hence it requires less complex circuit. It is highly susceptible to noise, which is it is highly affected by noise because noise mainly affects the amplitude of the signal since it is amplitude modulation technique. Also, AM is not power efficient as a large portion of power is wasted in transmitting the carrier of a signal. So even though its advantages, analog amplitude modulation in analog is still used in medium wave and short wave radio broadcasting systems. So this is why AM transmitters and receivers are simple and low in cost. So due to poor noise immunity and low audio quality, AM is not preferably suitable for high fidelity communication systems. So here is the waveform of the amplitude modulation techniques. So here the amplitude of the high frequency carrier signal varies with respect to the amplitude of the message signal, in which the frequency and phase of the carrier remains constant. So next one is the frequency modulation technique. So in frequency modulation, the frequency of the carrier wave is varied in accordance with the amplitude of the message signal. So here amplitude and of the carrier remains constant. So since noise primarily affects amplitude rather than frequency, as I already told, FM systems provides much better noise impurity uh, when compared to AM systems. So even though FM requires a larger bandwidth, it offers superior audio quality, making it more suitable for music and entertainment broadcasting. So in FM, the information is carried by the frequency deviation of the carrier signal. So larger message amplitude result in greater frequency deviation. So because of its better noise immunity and high quality audio output, frequency modulation technique is most widely used in FM radio broadcasting and television sound transmission systems. So FM on the whole, FM is of better noise immunity when compared to AM systems. So when we see the waveform of the frequency modulated signal, here the frequency of the carrier signal changes according to the amplitude of the message signal. Here amplitude of the carrier remains constant. So when the message signal amplitude increases, the carrier frequency increases, which results in closed spaced carrier cycles, as we seen in the third waveform. So here the frequency of the signal is varied in accordance with the uh, amplitude of the message signal. So next one is the phase modulation technique. So in phase modulation, the phase of the carrier signal is varied with respect to the message signal. So when the amplitude of the message signal increases, the phase deviation of the carrier also increases. So phase modulation is closely related to frequency modulation techniques, and hence the both techniques have constant amplitude characteristics, which makes them more resistant to noise. So FM and PM are of better noise immunity when compared to AM systems. So here in this modulation technique, information is communicated entirely through changes in the phase of the carrier signal. So phase modulation is widely used in digital communication systems and forms the basis for many advanced modulation techniques used in modern wireless communication systems. So when compared to AM systems, frequency modulation and phase modulation is of better noise immunity when compared to AM systems. So on the whole, without the need for modulation, reliable long distance communication would not be feasible. Therefore, modulation forms the foundation for all modern communication systems. So far we have seen amplitude types of modulation, amplitude, phase and frequency modulation techniques. So here is the frequency modulated waveform. Here, phase modulated waveform. Here phase changes accordingly with respect to the message, which is baseband signal. So here we will see the on the whole the amplitude modulation technique, frequency modulation technique and phase modulation technique. The amplitude, frequency and phase accordingly changes with respect to the message signal. So by go through the concepts which I explained before, try to answer these questions. Modulation helps in avoiding this and all I have explained. So try to answer these questions. Thank you all.